Okay, in this next part of lesson 2.9, we're going to talk about cameras. So this is going to be another example of combined variation, which we know there's going to be direct and inverse, both in the same equation. So photographers are always looking for ways to make their picture sharper. One way is to focus the lens at the hyperfocal distance. Focusing the lens at this distance will produce a photograph with the maximum number of objects in focus. Photographers often use the hyperfocal distance when taking pictures of landscapes. The two images at the right were shot with the same camera at the same settings, except the one on the bottom was taken with the lens focused at the hyperfocal distance, giving an extra degree of sharpness. So they're talking about this picture. It's just a little more sharp because it has the maximum number of objects in focus. Okay, in example 2a, the hyperfocal length h in meters, so we have h, varies directly, there's your key word, with the square, another key word, of the focal length L of the camera's lens in millimeters, and inversely, there's another key word, with the selected aperture f. The aperture is a setting that tells you how wide the lens opening is on a camera. So let's write that general variation equation, and it's a combined variation one because we saw the word directly and inversely. So I would say h, and I'm just going to read from left to right, h equals k, I got to have my k in there. It says h varies directly with the square of the focal length L, so L squared, don't forget that squared, and inversely with the selected aperture f, so divided by f. There is your general variation equation. That was part A. Step B, find the value and unit of k when the hyperfocal length h is 10.42 meters when using a 50 millimeter lens L, so we have 50 for L, and the aperture f is set at 8. So we have h equals 10.42, L equals 50 millimeters, and F equals 8. So we're going to find, they want us to find K. So we're just going to use this equation and plug in our values, this one right up here. So we have 10.42 is H equals K times L squared divided by F, which is 8. Solving for K, you should get k equal to 0.033, and make sure you do that squared first, and then divide by 8, and then multiply by 50. Or I'm sorry, divided by that 10.42. Make sure you can get that k value, or ask me if you're confused on that part. Okay, C, write a variation formula for the situation using your answer to part B. So now we're just going to take that equation that we wrote way at the beginning and put in k. So we're going to say h equals 0.033 L squared over F. That's all we have to do. And in step D, find the hyperfocal length needed if you want to shoot with a 300 millimeter lens at an aperture setting of 2.8. Include the units in your calculation. So now they have L is 300 millimeters and aperture of 2.8, so F equals 2.8. And I think the tricky part with this is just identifying what information they give you. And now they want you to solve for that hyperfocal length, which is H. So H equals 0.033, and I'm just using this equation there. L squared, so 300 squared, divided by 2.8. Work through the math and you should get H 1060.71 meters, because our unit for H is in meters. So that hyperfocal length is going to be 1060.71 meters. Okay, let's practice with another example for that combined variation. So this time, it's still the same. It says the hyperfocal length h in yards, though this time, varies directly with the square of the focal length L in inches and inversely with the selected aperture f. So we can read this from left to right and go h equals k times L squared divided by f. Remember to include that k. We have to include that k. It's very important. Part B, find k when your h, your hyperfocal length, h equals 12 yards. Be very careful. They throw in this little trick here. They say your hyperfocal length of a 1.75 inch lens is 12 yards. So that length, that hyperfocal length is 12 yards. Our L, which is our length of our camera lens, is 1.75 inches. And our aperture, our f, is 9. So I think the trickiest part about this is figuring out what value, or what is what. What does h equal, what does L equal, and what does f equal. So now we're going to plug all those values into that equation. So we can say h, which is 12, equals k times 1.75 squared divided by 9. And we should get k equal to 35.29. Now we're going to write a variation equation using that k. So we could say h equals 35.29 L squared over f. And then we're going to use that to solve for part D. And it says for D, find the hyperfocal length needed in yards if you want to shoot with a 12-inch lens, so that's L, at an aperture setting of 2.5. So L equals 12 inches, f equals 2.5. So we're going to solve for hyperfocal length h. So h equals 35.29 L squared, so 12 squared is 144, divided by f. Work through the math and you should get h equal to 2032.7 yards.